Yo, what's going on everyone? Welcome back to another video. And in today's video, I'm going to be introducing imaginary and complex numbers. And before we start this topic, I just want to let you know that there are two number systems. Okay. So look, we have two number system. Okay. We have two number systems. One is the real and the other one, so we know the real number system, but now we have another one which is complex, and inside the real number system we have integers, whole numbers, fractions, rational numbers, irrational numbers, etc. But now complex numbers, I guess you can say, are like, they're not undefined, but it's like, it's undefined, but there's a name to it, so it's defined. So many mathematicians, when we know the square root, okay, the square root of 25 is 5, okay, the square root of 36 is 6, but now there is an interesting case. What is the square root of negative 1? Okay, let's think. Do we have two numbers that multiply to get negative 1? Let's see, 1 minus 1. No, but they're not equal. Negative 1, negative 1, negative 1, and negative 1. No, that gives 1. So we have come to so look. So that's when mathematicians, I don't know the date, but I'm guessing it's maybe in the 19th century or something, that this is known as I. The square root of negative 1 was known as I because, like, I is the, let me write it here, where I is the imaginary unit. This stands for imaginary unit. Okay, so this is basically what imaginary numbers are. Okay, so imaginary numbers, if you have an overview, that's good, but basically imaginary numbers are the numbers that are not defined in the real number system. That's why mathematicians have made a whole new other system for these type of numbers. So okay, so I'm just going to erase this. I'm just going to write the square root of negative 1 as I here. So we know now the square root of negative 1 is denoted as I. Okay, so now that we know this, okay, now that we know this, we can dive deep into some other things. Okay, so I'm just going to block this because this is important to know. Okay, so look, now, yeah, I'm just gonna put on the side, imaginary numbers that aren't defined in the real number system. Okay, just gonna put that there. Okay, so like you can think of imaginary like something like, so like if you put this in a calculator, like if you put the square root of 1, it's gonna say keep it real, or like it's undefined, because a calculator only accepts real solutions. Okay, and so we can make a rule, okay, general rule here. Okay, wait, so general rule, negative number x, the square root of x is imaginary or complex. We're gonna get to that later also. Is imaginary, okay, slash complex. Okay, so the square root of x, a negative number, is imaginary complex. But let me go over this. So look, now that we know this, so look, now let me I'm gonna make some space. Okay, so now we can't say that, for example, if we have like suppose we have the square root of negative 2, we can't say this is I. No, because I is not just a variable, it's a unit. So look, if you have to find, look, you can think of this like as a, you can think of it as a formula, like the square negative 1 is I. You can think of it like that. So what would this, that's mean the square root of negative 2 would be I times the square root of 2, get it? Because in here we can write I times square root of 1. So this is the same as this, okay? So that's the general overview, okay? So I hope it's all clear to here. And look, if you have something, I'm just gonna put an arrow here, right here. Suppose we have something like the square root of negative 25. You can write this as I times the square root of 25, or we can write this as 5I, because the square root of 25 is 5. So this is 5I. Alright, so hope it's clear to here. 5I. But we do not, it's only positive, not negative, because as we know, the square root of any number is in its positive version, even complex numbers. So yeah, that's how it works. Okay, so I hope it's clear to you. You can take note of this also. Okay, I'm just gonna erase all this. Okay, I'm gonna delete all this. Just you can. Okay, cool. Now let's go to another topic. Solving equations with complex with. First, let me cover what are complex numbers. Okay, so complex numbers, consist an imaginary part in the where I is the imaginary unit, square root are real numbers. Okay, so this is a complex number. Okay, like for example, if we have 5 plus 3i, this is a complex number because this is a real and imaginary part, and it can also be negative. We can write it as 5 minus 3i, which can just be written as 5 plus minus 3i, but either way, this is a complex number. Okay, like yes, like we can also write imaginary numbers as complex. For example, if we have 5i, we can write this as a 5i plus 0, or we can write this as like that. We can write it as 5i plus 0, right? It fits the description. 5i plus 0. This is because in here this is a and this is b and this is I. So imaginary numbers can also be complex. Okay, so that's the simple definition. Now, I'll erase this. So I mean, complex numbers and imaginary numbers are used interchangeably. You can say either. Like for example, the I is also a complex number because we can write it as 1I plus 0, right? Okay, like for example, like I, we can write this as 1I plus 0. So this is A, this is B, these are the real numbers in the form A plus BI, and this is imaginary. Okay, now the next topic we're going to go through is solving equations with complex solutions, or you can say imaginary solutions. It gives the same meaning. Okay, so now for example, let's say I have the equation I'll give a hard one. Okay, if we have suppose we have x. Okay, wait. Suppose we have an equation x squared plus 20, okay, is equal to 5. Now look, before solving this, how do we know this has complex solutions? It's easy, because we know that when we add a number, how does it become smaller, right? And plus, we know that it's going to be negative if we transpose this, and if we take the square root, it will be negative. It will be a complex number. So let's try to solve this. Okay, first we're gonna subtract 20. Cool. Okay, there's the 1 here. Then now we're gonna get x squared equals 5 minus 20, which is negative 15. Algebraic numbers, yeah, okay. And then now we have to take the square root on both sides, and now we can put the plus minus sign here. In this case we can, because this is an equation. We need to find all roots. So now we get that x is equal to plus minus I times the square root of 15. So this is basically how to solve a simple equation. I know, yeah, we can plug this in the equation. Okay, so I'll just erase this. Okay, let's verify. So if you put this in the equation, plus minus I times root 15 squared plus 20 gives 5. Look, first, we know when a positive and negative version, no matter if a positive is being squared or negative, it will be positive. So plus or minus I squared, it will be negative 1. Because since I is equal to square negative 1, if we square both sides, we'll get I squared is equal to negative 1. Okay, so and then here we get square 15 squared. We know that the square of a square root is a number times 15 plus 20, and negative 1 times 15. We can rewrite this as minus 15 plus 20, and yes, this does equal 5. So yeah, we verified our solution. It's all good, and yeah, we're good. This is the solution. So now let's go to a little harder one. Okay, now that's just the basic of solving an equation. Like, You can also solve different types of equations. Okay, and now let's talk about another topic here. We're going to the fundamentals here. Okay, and in the same way, you can solve quadratic equations the same way. You can do it by factoring or completing the square or the quadratic form now. If it's imaginary, just leave it in its imaginary form. Okay, cool. Now the next topic we're going to do is simplifying complex expressions. Okay. I put imagine because complex might seem like the word hard, but it's just the imaginary the number system. Okay. Suppose we have something like this. 5i plus 3 into 3i. This is example, okay? Now you can try this yourself, okay? And then I'll solve it. Done? Okay. Let me solve it. First of all, you have to use the distributive property. First multiply this here, and then do it here. Like this. Okay. For example, 5i times 5 times 3 is 15. Okay, and I times I is I squared, which you can write. Let's just write for I squared now. 15i squared. Okay, 15i squared minus 25i, because 5 to times 25 with the I. Okay, now we're going to add 3 times 3, which is 9i, okay, minus 15. Okay, now let's clean this up a little bit. You can 15i squared can be written as minus 15. Let's write it like that. Minus 15 minus 15 minus 25i plus 9i. Okay, now just like we combine exponents, like on variable side, then we're gonna simplify this. Now if we have something like this, negative 20 plus negative 25i plus 9i will give you, okay, sorry, 16, right? So let's clear this up. Because negative 16i, negative 16i, negative 16i minus 15, and we can clear this up. Minus 15 plus minus 15 is minus 30, so we can write this as minus 30 minus 30 minus 30 minus 16i. There we go. This is our solution. Okay? Yeah. And okay, that we can double check, see if it's correct. Alright, that's a solution. Okay, and yeah, and yeah, we can divide also, but division would take a lot of time. Yeah, we can do that. Okay, I'll say division, and we can do multiplication. Alright, and 15i squared minus 25i plus 9i minus 15 minus 16i. Okay, yeah, I think this is the answer. Yeah, this is the answer. Alright, so now that we covered, now if you want to check this, you can divide this by this or this, but division is like division is a whole number. It's like a whole nother thing, I think, because yeah, let's try division. Okay. Now let's try to find this. What is it? We're gonna find 5 by plus 3. Okay, we're gonna find negative 30 minus 16i upon 5i plus 3. Okay. So, if you want to solve this, you can use the polynomial long division method. So keep it like here. Okay. So keep the bigger number right in here. Okay. 30 minus 16i. This is the bar, and then 5i plus 3. Like you have to do this how you normally divide. Okay, now this will distribute to these two terms. Okay, now let's see. Okay, look. First we have to divide 30 by 5i, which gives us what, 6, right? 6. 30 by 5. If you divide by 5, it will be 1. If you divide by 5, 6 by I. Oh no, that's bad. Oh god, we have a fraction. Okay, so we're gonna wanna put 6 upon I here, and then we're gonna wanna like do that. So I mean minus, because there's a minus sign. So we're gonna put a minus. So now we're gonna multiply this with this. Minus 6 by times 5y will be minus 30. Okay, and then minus 6y times plus 3 will be minus. Okay, I have to make that out. So the sign will be my negative. Okay, 6 by I times 3. 18 by I. Oh god, it's a fraction. I. So this will cancel out. Go get 0 here, right? And here we're gonna get plus 0 plus 69 plus 18i plus 18. Oh god, that's messy, bro. That's gonna be so hard to do. And I'm just gonna write it as like minus 16i plus 18 upon I. Okay, you know what? I'm gonna say this right now. Just don't do. Okay, yeah. Here, I learned something. Okay. Division by complex numbers gets really messy. It's not to use polynomial division or synthetic division. Oh yeah, I just figured that out. So I guess you can say, by my struggling, I guess you can say that because look, the thing is, polynomial division works only with real numbers. That's the thing. Okay? Polynomial division only works with real numbers. Okay, so I hope you enjoyed this video. Let me know if you want anything more, and I'll see you in the next video. Peace.